So for this one, it says a large stone hangs by a fine thread from a ceiling, and a section of the same thread dangles from the bottom of the stone. Okay? If a person gives a sharp pull on the dangling thread, where will the thread likely to break? Below or above the stone? So let's just kind of draw this. So I have a ceiling, and there's a thread. Then we have this great big stone that's attached to the thread, and then we have thread underneath the stone. Perfectly drawn thread, I might add. So this is my stone. Perfectly drawn stone, I should add. And they're saying, where is this thread going to break? Is it going to break above the stone? Is it going to snap here? Or is it going to snap here? Right, so here's Mr. Adams. I'm reaching up with my hand, and I'm going to pull on this. And where's it going to break? So when the person gives a sharp pull, the suddenness of the application of the force is key, right? So when a large sudden force is applied to the bottom of the string will have tension on it, okay? So let's label some of these things. So the bottom of the string will have tension, right? And so the bottom string would probably break first, right? But, so let's do this. So I'm going to say, let me type this up because there's two scenarios. So the bottom one will break if the motion or if the pull is quick, because the bottom one, the bottom string will have tension force. Now what they mean by that is in other words, if I pull down on this bottom string right here, if I pull down on this bottom string, there's a tension force because part of the string is connected to the stone and then part of the string is connected to my hand. So if I pull it quick enough, this will snap. Now the reason it snaps is because the stone, just like our previous example, has inertia. So that stone doesn't really want to move. It's not going to move. If I pull this real quick, that force could snap that string before that stone even moves. That's why the quick part is so important. Now, what do you think happens if I pull it slowly? Well, if I pull slowly, slow and steady, the bottom has tension, but the top will have tension too. So let's look at this. So what's going on here? Well, if I draw my stone in a separate, when I go slow, if I take my stone I have the force going down, right? So we could call this the force that goes down. But what else is pulling on the stone? Gravity, right? And then if the stone remains in place, then I have a force here, right, that's going up. In other words, the force going up, and this is the tension on the top string. The force going up is equal to the tension, or what I'm pulling down. We'll call this down. Plus the weight of the stone. So if I pull slow and steady, what's going to happen? The top string will break. Because why? It has more force being applied. I know you can't read it. I'll fix that in a second. Because it has the mass times the acceleration due to gravity of the stone too. So it's going to have a greater force. So the strings will break. There's a point in which the string will break. It's the same string. But the top string, if you go slow and steady, will reach that quicker than the bottom spring. Does that make sense? Okay. So that's a great conceptual question if you think about it. Okay. Any questions? All right. So now